So the reference geometry sample is running on the right side. If we look through the sample code, we first create a root segment, which is just any arbitrary segment that can be created out in the scene graph. And we'll create some subsegments chained down underneath. We'll first create a convenience segment called an include library underneath our root segment. And underneath that, we create a subsegment which we've named shell. And we have a key to that leaf shell segment. After setting up some structures for a point array that represents points in a pyramid and a face list, we set up a shell kit, which we'll cover a little bit later when we get to kits. As transactional objects is what we refer to them as. And in our shell segment, we insert a shell using this kit, and we're going to refer to it via the shell key. Once we have that, we have a triple nested loop here, and we'll build up a set of reference geometries. We'll reference this original shell multiple times down within this reference segment. So each reference itself will have a modeling matrix set on it to locate it in some specific location. So when we're all done, we call one of the view hierarchy's convenience methods. So we have a fit world, which will reset the camera so that it can view the current extents of the scene graph underneath that view. So it's a nice convenience method. We're going to orbit the camera just a little bit, and then we're going to do a special type of update on this canvas, which we'll cover a little bit later. This is a synchronous update rather than a standard update would be asynchronous. We're going to call a update with notifier wait. We'll cover that a little bit later. And this last fit world update is actually probably redundant. And so this is what we have. There's only one shell in the scene graph in our utility segment called shell key, and it's being referenced multiple times, 125 times, each with a different modeling matrix. So we're able to have a compact type of tree and reduce memory usage. So we could imagine if we had a very, very complex set of geometries that are going to be referenced many times, we could really reduce memory usage.